Okay, we're going to do one last example where we're starting with the same region as in the last exercise. So we're looking at the region bound by y equals x squared and the line y equals 2x. So I've just that portion of it, but we're rotating about the line x equals 2. So that's the vertical line passing through this endpoint here. So when we rotate it, we're going to still get washers. And sorry, that's not a very good graph, but we're going to have the parabolas flipped on this side and then the line. So if I look at any one, so first of all, let's realize that we are in terms of washers, and we're going to have to work in terms of y since we're rotating about a vertical axis. So if I take any one little slice, we can see the washer here, right? So when we set up our volume, we've got pi. We need to look for the appropriate bounds. We're going to have our larger radius, capital R of y squared. Outside, that's right, sweetie. And then minus little r of y squared. So let's look for that outer radius. That's the distance from the axis of rotation to the outer edge of my region, right? That's that region there. So how do I find that distance? So it's, okay. It's the distance, if you could take, that'd be great. It's the distance from this line to this line here. So this one's a little trickier than the last one. Sorry for that. The distance all the way from the y-axis all the way to the axis of rotation, that's obviously 2, right? Because we're going all the way from the y-axis all the way to the line x equals 2. So the full amount is 2. And then this little distance here between the y-axis and the line y equals 2x, we found that in the last example was that amount is x equals 2 over y. No, sorry, y over 2, right? That's this line, y equals 2x, but we would write it in terms of y. So that distance is y over 2. The full distance is 2. So I'm just finding the difference between those two. Capital R of y is going to be 2 minus y over 2. Okay, so let me explain that again. So the point is I'm going from the axis of rotation to the outer edge. So that's 2, the distance all the way to the axis of rotation, minus this part between the line and the y-axis, y over 2. So 2 minus y over 2. Okay, now let's do the same thing for the inner radius. The inner radius is the distance from the axis of rotation to the parabola. So again, we have to think about the full amount, that's the 2, the full amount from the y-axis all the way to the line x equals 2, and then subtracting off the parabola. Again, the parabola we're going to think of as x equals the square root of y. So our inner radius is going to be 2 minus the square root of y squared. So we've done all the hard stuff. Now we just need to find our bounds. In fact, we already found the bounds because it's from the last example. We're still working in terms of y, so our bounds are going to be from 0 to 4. And so there we go. That's the setup. That's what we would be looking for. And if you're interested, actually, you know what? I didn't even compute that one on my notes, so I'm not going to do that one. But that setup is what we're looking for.